the first thing we will be talking about is melting, boiling, evaporation. 3 topics we have to see. Okay. So first we will see the topic of melting. Melting. And whenever you try to see that, learn about melting, you will also be learning parallelly about freezing. Yes or no? We will see whether our knowledge is perfect or not. Okay. So let's say the state of matter is solid. Solid converts itself to liquid. This process is known as melting, and liquid converts itself to gas. This process is known as boiling, or vaporization will be a better word. Anything you can use. We can use boiling, and we can also use vaporization. Vaporization, right? And sometimes solid directly changes to gas. This process is known as sublimation. Are we fine with these 3 topics or not? Okay, right. Let's see the reverse order also. Immediately, let's see the reverse order also. A gas on cooling, so this will be known as condensation, will give you liquid, and a liquid on freezing will give you solid. और यहाँ भी sublimation होता है. This is called sublime and sublimates. जो भी है, ये हमारा इंटरेस्ट नहीं है, हमारे टॉपिक में ऊपर वाला ज्यादा इंटरेस्ट का है. Oh, hi Kirtan. I thought that you have also gone to the football ground as an ex-student. Oh, I see. Now you have been a great gate crasher in that case. Okay. Okay, chalo. Let's go ahead. So if you see melting as a process, melting is a heat intensive process. You have to actually supply heat, right? Q positive means we have to supply heat. And if we see boiling as a process, here also we have to supply heat. Do you agree or not? Right. Whereas if we see these 2 processes, ये जरा कुछ clear कर ले. Freezing में we have to take out heat from the system. Similarly, in condensation also we have to take out heat from the system. Are we fine on this basic structure? Right? चले. अब बात करते हैं सबसे पहले. Let's talk about melting. Melting. When we talk about melting, we will be dealing it with 2 criteria. One is pure substances. What are pure substances? Pure substances can be elements or compounds. What are pure substances? Pure substances are those substances which have only one type of particle in them. Element has only one type of particle, which is what? Atoms. And compounds have only one type of particle, which is molecules. Okay. Pure substances will have a fixed melting point. Melting point. And what is melting point? Temperature at which solid melts to liquid. Okay. So कुछ हमारे myths भी clear करेंगे. A pure substance or that is an element or a compound will have always a fixed melting point. When you are saying this statement, make sure you make one more statement, that at a constant pressure. So what do you want to say? That if the pressure should also be constant, you cannot vary the pressure. You cannot vary the pressure. If you vary the pressure, even pure substance will not show melting at one particular temperature. Let's say a common example. Let's say you want to boil potatoes. If you want to boil potatoes in a saucepan, it takes some time. And if you want to boil potatoes in a pressure cooker, it takes a different time. Because in both the cases, the pressure is different. Right? So we always say that what is melting? In melting, we will say a pure substance will always have a fixed melting point. एक pure substance का fixed melting point ही होगा. That is one particular temperature at which the solid melts into liquid. Right? So let's take an example out here. We say that at standard atmospheric pressure, what is the standard atmospheric pressure? 188. 1 atmosphere. At standard atmospheric pressure, water in the form of ice will melt to water in the form of liquid exactly at 0 degrees Celsius. Have you understood? exactly at 0 degrees Celsius, water will start to melt from solid to liquid. But इसमें बहुत सारा story है अभी. 0 is known as your melting point of ice or freezing point of water. यहाँ पे ये चीज कुछ ऐसा दिखा सकते हैं हम, ये भी दिखा सकते हैं. इसके बारे में अभी पढ़ेंगे. Okay. So what is melting? Melting, always remember children, we have discussed all these things in our chemistry class also. Melting is always a constant temperature process. Don't understand that at 0 degree, the entire water is going to melt into ice. We have discussed this before. At 0 degree, the first liquid droplet will form, means melting has got just initiated. Now this melting as a process keeps on continuing till when? Till the entire ice has not converted into water. Till that stage, we will call it as a process of melting. And in that process, what is important for us to understand is that the temperature remains constant. It's a constant temperature process. क्या इतना clear है? यहाँ से board मिटा सकता हूँ. कीर्तन, so far clear? Okay. So we are talking about melting. Salient points to be discussed right now is melting is a constant temperature process. Somebody knock on the door. Yeah, I have heard a sound. Melting is a constant temperature process, and during this process, melting is a constant temperature process. During the process of melting, the temperature does not rise, it remains constant. For example, if we say about melting point is that temperature at which melting just starts to initiate. And while you are observing this process of melting, you should have one criteria, that the pressure cannot change. So as an example, when we say that water melts in form of ice, water in the form of ice, which is a solid form of water, melts into liquid at 0 degrees Celsius, we try to say that this 0 degrees Celsius has been measured at standard atmospheric pressure, which is 1 atmosphere. अगर आप इस 1 atmosphere के साथ छेड़छाड़ कर दोगे तो इस melting में भी छेड़छाड़ हो जाएगा. So melting is a constant temperature process, and during this whole process, the pressure has to be constant. Is this much clear? And melting point is one temperature. And for a pure substance, it will always melt at this particular temperature only. Mixtures will show variation in their melting points, but a pure substance will always melt at a particular temperature. Now we got to start going deeper into it. Okay. So one of the best way to understand it is to take a temperature versus time graph. So let's take a temperature versus time graph. We've discussed this before in chemistry first chapter, but again we will give a dive to it. So, right. So let's say this is my time axis, time, and let's say this is my temperature. Is that understood? Okay. Now we have got ice with us. We'll see typically this example with ice. So we have kept some ice. So temperature of ice is less than 0 degrees Celsius. So ye niche hai. Have you understood? We are trying to heat ice now. Okay. Let me extend this so that it becomes more easy for you to understand. Okay. Now let's see the temperature profile. Let's see the temperature profile. So all the red arrows will indicate that heating is going on. So initially we start heating ice. We start heating ice, and then it reaches this temperature, which is 0 degrees Celsius. At 0 degrees Celsius. So out here, what is the state of matter that you will see? You will see solid, 100% solid, right? Then another thing that we will see is that the temperature will actually rise in this process. इस सब का इंपॉर्टेंस है, सारे पॉइंट्स नोट कीजिएगा. टेम्परेचर इज राइजिंग एट दिस प्लेस, ओके, एंड इट इज 100% सॉलिड, राइट? इट टेक्स सम टाइम. नाउ व्हेन यू रीच एट दिस पोजीशन, then what do we say? We say at this position, that is at this mark, the first liquid is observed. The first liquid is observed, and the interesting thing out here is that from here to here, temperature does not rise at all. The temperature is not rising at all. So out here I'll say during this phase, the temperature is constant. And let me name them as, say, 0, A, and let me name this as B, 0, AB. The temperature is constant. What is the temperature here? Sir, here also the temperature is 0 degrees Celsius. Out here was the first liquid observed, and at this particular point, it will be 100% liquid. It will be 100% liquid. So what about the state of matter between the process AB, solid as well as liquid, right? So AB is said to be the process of melting. Now start tallying whatever I said. Melting. I said melting is a constant temperature process. I said that melting is a constant temperature process. In my example, I'm using ice. So if you see, melting is happening at 0 degree. Temperature is constant. इस diagram को हम कैसे पढ़ते हैं? इसको हम कहते हैं heating curve. This is the heating curve. Are we fine? Melting is a constant temperature process. So what all we should see here? So we took ice whose temperature is below 0 degrees Celsius. We started heating. So if you see stage 0A, we will see temperature increases. Now our first question arises is that during 0A process, is heat being supplied? Yes, sir, heat is being supplied. Do you see the impact of heat being supplied? Yes, sir, I see the impact of heat being supplied, and that's why the temperature is rising. Question comes, during AB, what is happening? Are we supplying heat? Yes, we are supplying heat. However, the interesting part is the temperature remains constant, temperature does not rise, right? So here we need to first understand a little bit about temperature and heat. So what is temperature, beta? Temperature is equal to the average of kinetic energy. Average of kinetic energy. Which means that if there are particles, and in these particles, if the kinetic energy can go up, then the average kinetic energy, that is Ke bar, also goes up. If the kinetic energy goes up, the average kinetic energy also goes up. So only when the kinetic energy goes up, the average kinetic energy goes up, will you see what is known as an increase in temperature, and vice versa. Out here, if you see the process of AB, the temperature did not rise. So one thing we can conclude that in AB, the average kinetic energy did not increase. Yes or no? The average kinetic, yeah. Tell me, Ashmita. Yeah. Why did the average kinetic energy not increase? Average? No, because you are heating something. Heat is a form of energy. देखो ना, ये आपके पास molecules है ना? All the molecules are vibrating with some internal energy which we call as enthalpy. Some internal energy is there, internal energy. And at this stage, everyone is vibrating, so there will be some average kinetic energy, and that is known as the current temperature of this particular sample of substance. ये समझ में आया? Yes. Temperature is always a measure of the average kinetic energy. ठीक है? अभी आप इस सैंपल को हीट करना स्टार्ट कर देते हैं. यू आर सप्लाइंग हीट Q+. तो आप हीट एनर्जी दे रहे हैं. वेयर इज द हीट एनर्जी गोइंग? द हीट एनर्जी गोज एंड इंक्रीजेस द kinetic energy. The molecules which were vibrating now starts vibrating much more faster. Yes. And start leaving their space also. So the average kinetic energy goes up. So the temperature also goes up. Yes. Understood? Temperature is a measure of average kinetic energy. If you can increase the average kinetic energy, the temperature will rise. And when you heat, where does the energy go? The energy goes and increases the kinetic energy. That's why we see a rise in temperature. Okay? इतना आपको समझ में आ गया. Well, good. Now our question is, if we look at the process AB, okay? आप यहाँ पे ध्यान दीजिए. कहाँ पे ध्यान देने बोला हूँ? Process A and process B. If you look at in this process, in between 0 and A, 0 to A was a very natural behavior. What was the natural behavior? we started heating it and we did see a rise in temperature. The temperature rose up. But from A to B, we do not see any rise in temperature. Are we not supplying heat? Yes, we are supplying heat. So we will say that between A to B, right now, Ashmita and all, I'm talking about only the process AB. Between AB, the average kinetic energy did not rise.
Yes.
Therefore, the temperature remained constant. The temperature remained constant. K means constant. Okay. So the first question that comes is, where did the heat go? ये heat गया कहाँ? हमने तो heat किया ना, melting के process में. And now question arises, sir, this is the process of melting. Does the process of melting need heat? Yes, the process of melting needs heat. But where did the heat go? Because the temperature remains constant. तो यहाँ पे सवाल क्या आता है? This heat, ये जो heat है, remained what we call as hidden. हमें दिख नहीं रहा है ये heat. This heat remained hidden. And if it was not hidden, we would have seen its impact. And what is the impact that you see? The heat impact you would have seen was in the form of rise in temperature. So the heat remained hidden. Hidden का एक और word है latent. So this heat is known as latent heat. The heat that you are supplying in the process A to B. A to B के बीच में जो heat supply कर रहे हैं, इसे हम कहते हैं latent heat. ये heat तो गया, but where did the heat go? The heat remained hidden. Have you understood? Right. So we should now understand that why did the temperature not go up? So we will attack it again in the same format, that the kinetic energy did not go up. Then where did the heat go? So we say, let's say these are my molecules. These are my molecules. Now this is solid. Solid means molecules are held close to each other. Now, if you want them to become liquid, what should I do? I should increase their energy. Increase their energy so much that they can overcome the intermolecular force of attraction or interparticle force of attraction. So imagine that you have held me and you have tightened करके मुझे पकड़ के रख दिए हो, and I want to get free. Do I not need an energy? I need some energy. Whenever you hold something forcibly, right now when they are a solid, they are being held forcibly. What type of energy comes into picture? Potential energy. Energy by means due to by virtue of constraint. है ना? किसी भी चीज को अगर आप ऐसे बंद करके रख दोगे, suppose a spring, you have held the compressed the spring together, then what is the energy in the spring? Potential energy. Potential energy can be due to height. Potential energy can be due to a constraint also. A catapult being pulled, it has energy due to constraint. छोड़ दूंगा तो जाएगा. So these molecules which are right now in solid phase are actually held close to each other. They are all held too close to each other. The heat that you supply, the heat that you have supplied, it has gone and started to increase their potential energy and not kinetic energy. The heat is more significant in trying to overcome the intermolecular force of attraction. Look, in easy language, let us understand. When you supply heat, the heat has got two options. Either the heat can increase the kinetic energy, or the heat can, what do you say, weaken the intermolecular force of attraction. Do you agree or not? दो रास्ते हैं इस heat के पास. Either it can increase the kinetic energy or weaken the intermolecular force of attraction. How do you weaken the intermolecular force of attraction? By increasing the potential energy. Means an intermolecular force of attraction means what? Somebody जबरदस्ती पकड़ के रखे हो. The system is in constraint. So we are trying to increase the potential energy so that the system just gains enough potential energy so that it now gains the configuration of a liquid. मतलब दूर दूर जाना शुरू करे. Have you understood? Since there is no contribution to the kinetic energy, you do not see any impact on temperature. Have you tried to understand? Have you understood this process? When we look at the process 0 to A or OA, if you look at OA, at this moment, the solid is accepting the heat and the heat is going and contributing to the increase in kinetic energy. As such, you see a rise in temperature. But as soon as it starts to melt, that is the point A. At A, the first liquid has happened. And then what is happening between A to B? Sir, solid as well as liquid. And at B, sir, no more solid seen. Everything has converted into liquid. So A to B is the process of melting. During this process, the temperature remains constant. Why does the temperature remain constant? Because, sir, the average kinetic energy does not go up. Okay, understood? But we were heating out here. Was heat supplied in this process? Absolutely. So I'm writing this also. Okay, I was supplying heat in this process. I was supplying heat in this process. Was I supplying some heat in this process? Yes, sir. You were supplying heat in this process, but I'm writing it as QL. This heat is different from this heat because this heat's impact is seen in the form of rise in temperature. But for this heat, we are not seeing its impact. The heat has gone hidden. And this is why it's known as latent heat. Have you understood? What does latent heat do? Latent heat actually goes and starts increasing the potential energy of the particles, intermolecules or the particles of matter. And once they get potential energy, they are able to break the constraint, which is currently their solid form, and get into a new form, which is liquid. जब तक वो पूरा लिक्विड बन नहीं जाता है, वो सिर्फ कंस्ट्रेंट्स को तोड़ रहा है. उसको तुमने बहुत जगह बांध दिया है, हाथ पांव सब बांध दिया. It is trying to get out from all the constraint. Once it has got out in all the constraint, it is constraint free. It does not need any jack up in its potential energy. Further, if you heat, its kinetic energy will go up. That means again you will start seeing rise in temperature. Is this clear or not, bachcha log? So the process that is SNL, look at this stage AB. AB के बीच में the stage जिसको आप melting बोलते हो ना, melting का एक और नाम होता है, melting बोल के नहीं, the process from A to B, you are seeing two states of matter, right? Our Kirtan plays drums. If somebody is playing, say, Indian musical instrument like Mridangam with him, we call it fusion. Fusion of Western and Carnatic. Because he is playing Western, somebody is playing Carnatic. Similarly, here we are seeing fusion of two different states, solid as well as liquid. So this particular latent heat, where did the heat go? So this heat is called latent heat. And since it is happening from A to B, which is the process of melting, this latent heat will get a special name, which will call it as the latent heat of fusion. The latent heat of fusion. And we will denote it as LF. तो QL की जगह हम इसको नया नाम दे देते हैं. हमने इसको नाम दे दिया LF. Have you understood? Q was the heat which was supplied for the solid till the solid change. 1 minute better, till the solid changes just to liquid. Once it has changed to liquid, what has started? Melting has started. And the melting is a constant temperature process. During this process, is heat required? Yes, heat is required. That heat is special because the impact of that heat is not seen in rise in temperature. So what do we say about that heat? That heat has got hidden. So we call it latent. And latent heat is happening, is getting supplied during which process? A process where solid is transforming to liquid. One state of matter is transforming. Does everything happen in one go? No, sir. Solid, liquid, 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 liquid. So there's a fusion. So we call it as latent heat of fusion. Latent heat of fusion. And I'll get to you, Ashmita, 1 minute. So if somebody asks me, how do you define latent heat of fusion? I will measure this latent heat of fusion also in the units of kilojoule per kg. I will say that it is the amount of heat. Sunte jao pehle. It is the amount of heat required to melt unit mass of a substance completely at constant pressure. Who is responsible for melting? Only latent heat. So if I say the latent heat is say X kilojoules per kg, that means ice needs, for every kg of ice, you have to supply X kilojoules to melt 1 kg of ice completely to water. So the definition says it is the amount of heat needed to melt unit mass of a substance completely from solid to liquid. Complete होना है. जब तक complete नहीं होता है, लेटेंट हीट का फुल मेजरमेंट नहीं आता है। तो लेटेंट हीट को आप कहां से कहां तक मेजर करेंगे? यहां से मेजर करना शुरू करेंगे यहां तक। Say if you are trying to heat it with an electric heater whose power is given to you, power into time is energy. So कितना देर आपने आप you don't have practical, so you can get ATP based question. So how do you measure the, if somebody says try to measure the latent heat, कैसे measure करेंगे? We will see, we will start जब पहला drop of water will be formed. That's the best we can do. We'll start our stopwatch until whole ice has melted into water. We'll close the stopwatch. We know the time, we know the power of the heater. Power multiplied by time gives me what? Energy. So that means that much of energy, right? And you know the mass of ice that you took, so divide it with that mass, so you get kilojoule per kg. Ashmita, your question now. ठीक है, समझ में आया? हाँ, यहाँ पे जितना सवाल पूछना है पूछो, क्योंकि आगे भी जाएगा, इसमें बहुत ग्राफ और एटीपी टाइप क्वेश्चंस पूछ देगा आपको। आपको कोई भी डाउट है आप पूछते जाइए। या सॉलिड टू लिक्विड? नो, फ्यूजन में हम हमेशा सॉलिड टू लिक्विड को ही फ्यूजन बोलते हैं। इट्स कॉल्ड लेटेंट हीट ऑफ फ्यूजन। हैव यू अंडरस्टूड? Latent heat of fusion. It is the amount of heat required to melt 1 kg of a substance completely from solid to liquid at constant pressure. ये मत भूलिए, because melting is a constant pressure process. All these things happen at constant pressure. आप pressure को छेड़छाड़ नहीं कर सकते. You can't play with pressure during this process. All these are happening at constant pressure. Have you understood? ठीक है? Can I take off some things from here now? Okay. I'll be very selective in removing things. So I am removing this part, right? And I am also removing from this part. Are we fine? Right. Some few more things that we need to discuss about. So we have understood what is melting. In our heating curve, process AB represents melting, and the fellow who is responsible for melting is known as the latent heat of fusion. Latent heat of fusion is measured as kilojoules per kg, and it is responsible for melting unit mass completely from solid to liquid. That means 100% conversion should happen. Have you understood? 100%. Now, how to attack problems related to latent heat? So far you have got one expression with you from the previous chapter, Q equal to MC delta T, or in some books it is written as MC delta theta. Yes or no? Right. Amount of heat absorbed by a substance is directly proportional to its mass, the specific heat capacity, and the difference in temperature. अब जरा देखो यहाँ पे बड़ा इंटरेस्टिंग हो जा रहा है. If you are talking about latent heat, then this delta theta does not make, or delta T does not make any significance, because there is no change in temperature. There is no change in temperature. So you will think, sir, let us put delta T as 0. But that would be a very foolish option. Delta T 0 मतलब heat supplied भी 0 हो जाएगा. अगर ये साइड 0 है तो ये भी 0 हो जाएगा ना. तो ये एक्सप्रेशन को हमें थोड़ा सा क्या करना पड़ेगा? We have to little bit massage it. So that little bit massaging is like this. We say LF is equal to M into, sorry, Q is equal to, sorry, Q is equal to, we write as ML. ML means LV, not MC delta T now. ML. You should try to always ask whether you are correct. Q will be measured in what? Kilojoules. M will be measured in kg. LV is measured in what? Sorry, LV nahi, LF. LF is measured in kilojoules per kg. Kg cancels, so our expression is correct. What is Q? Q is the measurement of exact amount of latent heat. अच्छा, अभी थोड़ा सा फिर से देखते हैं, आपको थोड़ा सा कंफ्यूजन हो गया होगा, सॉरी, आपको थोड़ा सा कंफ्यूजन हो जाएगा होगा. So how does the equation change? The equation changes as Q equal to ml. L means out here, L is LF. What is M? M is the mass and LF is latent heat. Now you will say, what does Q give me? Q gives me the actual amount of heat needed based on mass taken. What do I mean by this? What do I mean by this? If I am working with ice, ice has got a fixed value of LF. Fixed value. Why? Just समझ लो. What should be the value of LF for ice? The value of LF for ice will be something kilojoules per kg of ice. Per kg of ice. But our friend Dhruv is saying that he wants to melt 5 kgs of ice. And you want to measure how much heat was required. In that case, what will you do? You will multiply the latent heat. Latent heat is like a rate, ना? 1 kg को मेल्ट करने के लिए ब्ला ब्ला किलो जूल्स चाहिए. आपको हिसाब चाहिए कि सर 5 kg मेल्ट करने के लिए कितना हीट चाहिए. तो 5 kg मेल्ट करने के लिए LF into mass. Kirtan, have you understood this clear? In the previous problems that we were doing, we were not talking about melting or boiling. We were just talking about heating. Okay. Now, one catch. Look here. Look at the process OA. If somebody tells you for the process OA, calculate heat. How will you calculate? Yes, for process OA, we will calculate Q is equal to MC delta T. Because here there is only the case of heating, which was there in our previous unit. We are only bothered about how much mass of ice we are heating, what is the specific heat of ice, and what is the change in temperature. Once you are, suppose you are bringing it from -15 to 0 degree. So change in temperature is how much? 15 degree only, not minus, 15 degree only. समझ में आया? Ashmita, did you understand? ये फेज में अगर आप प्रॉब्लम करोगे तो Q इक्वल टू MC डेल्टा T. ये फेज में प्रॉब्लम करोगे तो Q इक्वल टू LV, sorry, LF. Correct? Okay. Few more things about melting before we go ahead. इसलिए मैं आज का क्लास इंपॉर्टेंट था. I didn't want these girls to miss today's class. So this concept, no matter how much you see on recording, when it is live, you can ask many questions. Okay, so let's take this also off. One more, something more that we'll discuss now. Again, let's go to melting. So tell me one thing. During the process of melting, and you can agree or disagree with me, tell me, yes or no, do you think heat is supplied to the system during the process of melting? Obviously, नहीं तो वो melt होएगा ही नहीं ना. Heat is supplied. Our answer would be a big yes, but a special sort of heat, which is known as latent heat of fusion. But latent heat of fusion only when the mass is equal to 1 kg. If your mass is equal to m kg, then the total quantity of heat that you are supplying is equal to m into LF. Understood? If it is 1 kg, how much heat you supplied? LF. If it is more than 1 kg, you are supplying MLF. ठीक है? तो जब हीट सप्लाई हो रहा है, किसको हीट सप्लाई कर रहे हो बेटा? आइस को हीट सप्लाई कर रहे हो ना. दिस इज योर आइस. इसका मतलब आइस को हम क्या बोलेंगे? आइस इज आवर सिस्टम, एंड सिस्टम को सराउंडिंग से हीट आ रहा है. दैट मींस दिस प्रोसेस ऑफ मेल्टिंग इज ऑलवेज अ एंडोथर्मिक प्रोसेस. Melting is the endothermic process. Endothermic is that process in which heat is supplied to the system. What is your system? Sir, ice. Will ice melt on its own? No. It has to gain heat. इसीलिए जहां ice melt होगा, वातावरण ठंडा होगा कि गर्म होगा? Surroundings If ice is melting, that means ice is absorbing heat. So the surrounding should cool. No, the surrounding has to cool. Ice itself temperature will go up. The surrounding has to cool. इसीलिए तो बर्फ रख के ठंडा करते हैं ना. In every process where latent heat comes into picture, the system will absorb heat. The surrounding will always cool. Evaporation. कहीं भी वैसे evaporation में latent heat आता नहीं है. Let's say a process like fridge के अंदर, if you try to melt something, then आसपास ठंडा होएगा ही होएगा. Take a packet of milk from your deep freezer, which is just like a rock, and put it on a saucepan. Saucepan पूरा ठंडा नहीं हो जाता है. Because how is the milk melting? The milk must be drawing heat from somewhere, na? Where it is drawing the heat from? It is first draw the heat from the body of the saucepan itself, conduction. Then there will be some convection and some radiation. So the first impact we will find on what? We'll find on the saucepan. Saucepan ठंडा होना शुरू हो जाएगा. ये clear हुआ? Okay. Let's see some important, facts about latent heat. Now let's see some facts about latent heat of fusion. Now say suppose I have water in liquid form and I've been able to keep it at 0 degrees centigrade, and I have got ice, that is water in solid form, at 0 degrees centigrade. Okay, water at ice and water, this is nothing but ice, right? और ये मान लो ये किसी का हाथ यहाँ पे burn हो गया है, somebody's hand has received a burn, and you now to give comfort to this person, you have the option of water at 0 degree and ice at 0 degree. We always prefer ice. The reason is that ice at 0 degree means you have put the hand here at point A. How do you give relief to the person? By cooling the person. You have to withdraw heat from his hand has suffered a burnt. That means the hand is hot right now. His hand को ठंडा करना है. ठंडा करना है मतलब hand से heat withdraw करना है. तो हमने hand को यहाँ रख दिया. And who is withdrawing the heat? Ice is withdrawing the heat. But will the ice melt immediately? No, the melting is a delayed process. Till that time, the person will get comfort. However, if you would have brought the hand out here, he initially gets comfort of 0 degree, but out here everything is liquid. So slowly, the liquid temperature will start rising, heating hona shuru ho jayega. The person will not get that much of comfort. Ice can keep on absorbing the heat, yet maintain the temperature at 0 degree, and it will take some time for ice to melt to water. Another example of it is specifically the cool packs that you get. The cool packs that come with your ice cream. If Blinkit and other people are shipping ice cream to your home, they will ship the ice cream in cool pack. Now what is happening in this cool pack? They are better than ice. Say if ice melts over say 3 or 5 minutes, this cool pack will start melting over 30-45 minutes, allowing the person more time and comfort to deliver the item still in frozen state. समझ में आया? इसका टेम्परेचर नहीं है, तो किसी का हाथ जलने से हम उसे आइस देंगे, ना कि वाटर, बिकॉज वाटर होते होते इट हैज ऑलरेडी अब्सॉर्ब हीट, वो और हीट विड्रॉ नहीं कर पाएगा, लेकिन आइस में अभी भी कैपेसिटी है और हीट को एब्सॉर्ब करने का, येट शो नो चेंज इन टेम्परेचर, यहां तक वो 0 डिग्री रहेगा. एंड पर्सन इज कंफर्टेबल नॉट बाय लेटेंट हीट एंड ऑल, पर्सन इज कंफर्टेबल जब तक 0 डिग्री है. जैसे 0 से अल्टीमेटली यू सी ना, ये हाथ जल गया है, दिस इज एट सम 60 डिग्री सेल्सियस एंड दिस इज 0 डिग्री सेल्सियस, दिस इज द गैप. ये गैप जितना ज्यादा रहेगा, द पर्सन विल फील मोर एंड मोर कंफर्ट. इफ यू वुड हैव पुट वाटर, then water's temperature will immediately rise to 10 degrees centigrade. So now the delta is how much? 50. Person does not feel comfortable. He will feel more comfortable if the difference is more. Is melting understood now? Constant temperature process. There will be a lot of ATP questions, and in ATP questions, one of the questions that comes is, why do you see the graph horizontal? The graph horizontal means it shows a stage of fusion. Fusion means from solid to liquid. It's actually depicting the process of melting. Melting is a constant temperature process. A pure substance will always have a fixed melting point. Water will has a fixed melting point of 0 degree when the pressure is 1 atmosphere. That is standard pressure. Okay. Melting is a endothermic process. During the process of melting, the substance gains heat and changes its state. However, the surroundings cool. And the heat absorbed by the substance nowhere shows any sign in increase of temperature. That means that heat has got hidden. That's why we call that heat as latent heat. And since the latent heat was used in the process of fusion, we call it as latent heat of fusion. And during this process, the heat came and it had two options, either to increase the average kinetic energy or to weaken the intermolecular forces. In other words, it went and chose the second path, that is to weaken the intermolecular forces. So what do we say? It actually increased the potential energy because system was under a constraint. I am solid, I am closely packed, I am under constraint. In order to release my constraint, I need more potential energy. So heat gave potential energy and did not contribute anything to kinetic energy. That's the reason I don't see any change in temperature. इससे और ज्यादा क्या बोलना है? Clear? Right, very good. चलिए अभी थोड़ा और आगे चलते हैं and let's get into the process of now. इसको further करते हैं, इसको हम heating curve बोलते हैं, ठीक है? So if a problem comes, always remember it is Q is equal to
Sir,
ml. Yes sir, बोलिए.
so
हाँ.
when you add heat and the temperature increases, the average conduction to particles.
Yes.
But if the temperature does not increase,
That means the heat which you have supplied did everything in this world rather than increasing the kinetic energy. Now you should ask, what everything in the world did you do? It has only one option to change potential energy. You can increase potential energy only when state change is happening. अभी जैसे हम आगे देखेंगे, अभी देखो B पे क्या हो गया बेटा, 100% लिक्विड हो गया है ना.
yes,
अब आप लिक्विड को इमीडिएटली गैस तो नहीं बना सकते, लिक्विड लिक्विड ही रहेगा, है ना, तो थोड़ा टाइम लगेगा. So let's see this next part of the graph. So what happens on the next part of the graph is that now if I start heating it again, now the temperature again starts rising. ऐसा टेम्परेचर राइज करना शुरू हो जाएगा, ठीक है. इस प्रोसेस को हमने क्या नाम दिया? इस प्रोसेस को हमने प्रोसेस BC बोला. इस प्रोसेस में हीट इज बीइंग सप्लाइड अगेन प्लस, और ये हीट कैलकुलेट करने के लिए अगेन वी विल यूज MC delta T, राइट. What is the heat doing in this case? In this case, the heat is responsible for increasing the average kinetic energy. That's why you are seeing, that's the reason you are seeing a rise in temperature. Simple as that, right? ऐसा करते करते एक पॉइंट तक जाएगा, और क्योंकि हम अभी किस चीज के ऊपर डिस्कस कर रहे हैं, वी आर डिस्कसिंग अबाउट आइस. सो दैट पर्टिकुलर एक पॉइंट, सॉरी, दैट पर्टिकुलर एक पॉइंट विल बी नथिंग बट अ टेम्परेचर ऑफ 100 डिग्री सेंटीग्रेड, है ना, 100 डिग्री सेंटीग्रेड. once, because we are dealing with water, once it reaches 100 डिग्री सेंटीग्रेड, अच्छा यहाँ पे स्टेट ऑफ मैटर क्या है? द स्टेट ऑफ मैटर इज ऑल लिक्विड, 100% liquid, everything is liquid out here. So at C, what is the observation we will find? We will find the first vapor formation, the first vapor formation, ठीक है. और जैसे यहाँ पे हमें vapor formation देखना शुरू हो जाएगा, what we are going to observe now is that for another good for some time, the temperature will again become constant till we reach a point which is D. D पे हमें क्या मिलेगा? 100% वेपर मिल जाएगा. So between this and this, what we'll get liquid as well as gas. Again एक तरह का फ्यूजन, पर इसे हम फ्यूजन नहीं बोलते हैं, इस प्रोसेस को हम बोलते हैं वेपोराइजेशन. वेपोराइजेशन, और दिस प्रोसेस इज आल्सो नोन एज बॉइलिंग. तो आइए बॉइलिंग के ऊपर कुछ इंपॉर्टेंट पॉइंट्स लिखना स्टार्ट करते हैं अबाउट बॉइलिंग. In my graph, it is represented by CD. Yes or no?
yeah,
It is represented by the process CD, and CD is again a constant temperature process. Constant temperature process, and this constant temperature will be known as my melting point. And remember, if you are again a pure substance, okay, if you are pure substance, you will have a unique melting point. which for my case in water is 100 degrees centigrade. Pure substance will not melt over 100, 101, 102, nothing like that. Any doubt? Sorry, melting means boiling point. Pardon my words. So if you, what I'm trying to say is that CD is the process of boiling. Boiling is a constant temperature process, and that, I'm so sorry, I'm sorry. Let's write it once again. I'm sorry. क्या है, फ्लो हो जाता है ना. So we are talking about boiling. Boiling is represented by the process CD. Boiling is represented by the process CD, and CD is a constant temperature process. During this process also you should ensure that pressure is constant. Pressure को कभी आप छेड़ नहीं सकते हैं, and this constant temperature is known as the boiling point. And if you are a pure substance, then your boiling point will be unique, which for water is 100 degrees centigrade. Question arises, did you not supply heat during this process? Yes, we did supply heat. Heat was supplied here, but this heat is known as the latent heat of vaporization. Again, we did supply heat. Where did the heat go? Sir, the heat remained hidden. The heat did not increase any kinetic energy. So the latent heat of vaporization was responsible for jacking up the potential energy, and it did not contribute anything on the kinetic energy. As a result, you did not see any change in temperature. However, the constraint was broken, and now the liquid particles started to move more far apart till they broke one shackle and became gas. And they keep on breaking their shackles until they reach a point where they are completely free from any constraint. They do not need any more potential energy increase from D onwards. But if you are still a very kind-hearted person and you feel that you will keep on heating, they don't mind. After that, again, the temperature starts rising. And at this stage, the type of steam that we get, this is steam, and this steam is known as superheated steam. And there's a question sometimes you get in ATP, right? Why do engineers use superheated steam for heat transfer? Because superheated steam contain maximum amount of heat, not only the latent heat plus additional heat also. If they would have taken the first steam from here, it would have taken some portion of latent heat. So the latent heat, entire latent heat. So a very nasty question, if you want to give someone torture with burns, should you throw 100 degrees water or 100 degrees steam? 100 degrees steam, because 100 degrees steam contains much more heat than 100 degrees of water. That's why engineers will always use superheated steam. Superheated steam means there is no more water left. In engineering, we say the dryness fraction is equal to 1, completely dry. How many of you have ever had the exposure of going to some, say, not in shopping malls, I'd say, to your dad's office or somewhere where you have coffee vending machines? In that coffee vending machine, you'll always see a J type of a pipe which is there to take the steam, and it creates more froth. Have you seen that? So the coffee vending machine usually vends coffee at a normal temperature. Say our friend Ashmita has gone and she's trying to take coffee from the coffee vending machine, but she's not liking the temperature or the hotness of the coffee. She wants it more hot. What is the option she has? Immediately to put the mug on that steam vent and start pressing that button. So it will say and will immediately heat up the coffee. हर coffee machine में एक steam vent रहता है. People take it because somebody wants, cappuccino, latte, mochaccino, or whatever it is to have more and more of froth. So it gets it. Have you understood? Steam produces much more burn. So are we fine with the process of boiling? So is boiling endothermic or exothermic? It is also endothermic. Boiling will happen only when this comes. So let's define what is latent heat of vaporization. The latent heat of vaporization is defined as the amount of heat. Now, how will we express this? We are going to express this also in kilojoules per kg. Is the amount of heat required to vaporize 1 kg of a liquid, or unit mass of a liquid, we don't say kg, unit mass of a liquid completely to its gaseous form is known as the latent heat of vaporization, right? And latent heat of vaporization is always a fixed quantity because this heat is measured per kg of the substance. But if you say, no sir, I actually have 2 gallons of water and I want to make it steam, then it will be multiplied with the mass of that water. ये रेट की तरह है, 5 रुपए पर केजी, तो फिर सर 25 केजी का कितना दाम होगा? 25 into this, as simple as that. So in this stage, if somebody asks you to do a problem, how would you do Q as? Q equal to M LV. In this stage, it will be Q equal to MC delta T, Q equal to MC delta T, Q equal to MLF MLV. फंडा क्लियर हुआ कि नहीं बताओ? ठीक है. So let's say in the exam, instead of giving you a heating curve, there is one example out here in your book which says about, I want you to read it on your own, the cooling curve of stearic acid. So there is an experiment. Obviously, you will not do the experiment, but you can get a question. So cooling curve कैसा होगा? Just उल्टा होगा इसका. So cooling curve will start from here. They are trying to cool it, and then there will be a constant temperature process, which is actually the process of condensation. In cooling, I will call it the process of condensation. So in condensation, what is happening to latent heat of vaporization? This has to be sucked out. The latent heat of vaporization has to be sucked out. Then what will happen? Entire mass of gas will convert to entire mass of liquid. After that, again, we will be withdrawing heat. This will be a withdrawal process. And then we hit a process where we first see the formation of solid. And from there, our job will be to suck out the latent heat of fusion. And we are progressing on the process of freezing. And then we reach 100% solid. ठीक है ना? So यहाँ पे हमारा गैस, यहाँ पे पहला लिक्विड दिखेगा, कंप्लीट लिक्विड, फिर ठंडा करते 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 पहला सॉलिड, कंप्लीट सॉलिड, उल्टा करके आएगा. और एक सवाल आपको पूछ सकता है that what is, why do you, जैसे ऐसे यहाँ पे एक क्वेश्चन है, the cooling curve, a plot of temperature, and this is a cooling curve plot. They are showing why between A and B the curve is flat, because during that process freezing is occurring and it's a constant temperature process. Okay. So have we understood latent heat of fusion and latent heat of vaporization? So in your book after that we have something called the change of state and the kinetic particle model. That's exactly talks about what I have spoken. What does the latent heat of fusion do? The latent heat of fusion goes and increases the potential energy because the particles were in a constraint. And once they are increasing potential energy, they are not contributing anything to jack up of kinetic energy. As such, you don't see any rise in temperature. Clear? तो ये वाला चीज भी हमने पढ़ लिया. So कुछ questions देखते हैं. Like say, why is ice good for cooling drinks? You've got some say bottles of beverages and you want to cool them. Should you use water or should you use ice? I will say I will use ice. Remember, here we are not talking about dry ice. Dry ice is not water. What is dry ice? CO2, carbon dioxide. That's a sublimation process. If you go to fish market and all, there everyone uses dry ice. उतना ice पिघलेगा तो पूरा fish market पानी के नीचे चला जाएगा. सोच के देखो. When you go to these supermarkets and you see the fish market or the meat frozen area, they are not water ice. They are all dry ice. So when they, so here they are asking, why do you use ice for cooling? Because ice has the capacity to absorb more heat, yet not show an increase in its temperature in the process of its melting. Therefore, ice is more preferred for cooling drinks. Have you understood? Okay. Why do engineers often use superheated steam, that is beyond 100 degree? Superheated steam is supposed to contain the maximum amount of heat. So if anyone has to transfer heat from one point to another point, how do you transfer heat? Either you allow a hot liquid to flow or you allow a hot gas to flow. I ensured that I am flowing superheated steam where there is no question of any water or moisture, and it is the maximum content of heat that somebody can take. Okay, right? तो ये वाला पोर्शन भी हमने देखा. And now we talk about boiling and evaporation. Okay, boiling also we have spoken. What is boiling? Boiling is a constant temperature process where 100% liquid converts to 100% gas under a constant pressure. During the process of boiling, who plays the role? Latent heat of vaporization plays the role. It is an endothermic process. अच्छा, यहाँ पे ये कहानी खत्म होता है. So I'm taking this off. If any question is there, you can ask. There is now one more thing called evaporation. Evaporation versus boiling. Okay, you will see that on a fine day, the rate of evaporation is more. On a fine day, the rate of evaporation is little bit less. है ना? आप कभी घर में पोछा मारते हो तो कभी कभी कैसा रहता है, घर जल्दी सूख जाता है. If it is bright, sunny, टकटका hot, you will see that your floor is getting dried very quickly. If it is a rainy and soggy day, then your mother will say either you mop with absolute squeezed mop or you don't mop because it's not going to dry. चप चप रह जाएगा, है ना? So evaporation का जो rate है, evaporation is also a process where liquid is getting converted to gas. This is also a process where liquid is getting converted to gas. What are you mopping your house with? Sir, water, pure substance. What are you boiling? Sir, water, pure substance. Boiling will always have a fixed temperature, which is known as the boiling point. Evaporation will have a variable temperature, and this evaporation will vary or depend upon some number of factors which we'll discuss. Before that, we need to understand what is the process of boiling. वैसे आपके बुक में नहीं है, पर जान लो boiling कैसा रहता है, right? So when you start heating any liquid, so where does the heat first go? The heat first goes into the bottom part. ये bottom part गर्म होता है. And जैसे जैसे आप पानी गर्म कर रहे हो ना, ऊपर हाथ लगाओ कुछ नहीं होगा, नीचे ले जाओ हाथ गर्म लगेगा. So the bottom part gets heated, and as such it gets lighter. So these lighter water particles go up, and whatever water particles are here, they will push them down. So this is sort of a convection current. Very good. This is a convection current. Like in our house, we have got doors and windows at one level and ventilators at the top. So when the house heats up, the hot air is supposed to go out by the ventilator, and cool air is supposed to come from the doors and windows. ठीक है ना? So boiling is a process where a convection current is set up, where the bottom portion of the particles will first get heated. They will rise up and push this, and this goes on happening till the kinetic energy of all the particles now becomes sufficient enough, or initially we'll say the potential energy of the particles become now sufficient enough to break the shackles, and the boiling will happen at a fixed temperature. Everything will start boiling. It's a complete process. Whereas when you talk about evaporation, evaporation is always a surface phenomenon. Evaporation is a surface phenomenon. Here the water molecules which are right at the surface, sometimes due to some action of nature, gains energy sufficient enough to escape from here, and that is evaporation. And what are those? I would say evaporation is directly proportional to temperature difference. Okay, evaporation is directly proportional to surface area. One of the scoldings that you guys might be getting in your house is after you have your bath, you must be dumping the towel on the bed, and your mother will be shouting on you that spread the towel. Why do you spread the towel? देखो अस्मिता को पता चल गया, यही मेरी कमजोरी है. Why do you spread the towel? You spread the towel because you are increasing the surface area. Towel सूखेगा जल्दी, है ना? कोई भी चीज हम ऐसे करके खोल देते हैं. So evaporation has directly proportional to surface area. If you take your vest or your shirt and you spread it open, it will dry quickly. And if you keep it in a lump, but boiling में ऐसा कुछ नहीं है कि आप spread कर दोगे तो जल्दी boil होगा, ऐसे रखोगे तो नहीं. तो boiling fix में ही होता है. अच्छा, next is what is known as the wind draft. Sometimes the wind will provide this draft spelling is actually D-R-A-U-G-H-T, wind draft. Okay, or draft. This wind will actually give you sufficient energy for these molecules to escape. Surface phenomenon. Okay? After rains, there is a muddy puddle or a water on the road, and by the time you come back from school, the water dries out. Evaporation happened. Okay. And also one more point which your book does not mention, that is humidity. If you go to Vizag or if you go to Chennai, then no matter how much under the sun you have kept your towel, if Kirtan has observed it in Chennai, this towel will never dry down. That's because the water vapor content is more. Evaporation as a process is also endothermic because ये भी heat absorb कर रहा है. And whenever evaporation happens, surroundings get cooler. The reason is what? Just see. Right now there is an average kinetic energy. Okay, let's call this as Ke1. Right now there is an average kinetic energy which is called Ke1. Wind came and took away these 4 molecules along with it. ये 4 molecules को अपने साथ ले गया. Don't you think the average will fall down now? Average में change आ गया. The average kinetic energy gets disturbed. So this particle has, when it absorbs the heat, the average kinetic energy of the other side. अभी इसका जो average kinetic energy है, let's say this is average kinetic energy is K2, this part. We say that in evaporation this should cool and this will heat. Obviously, let's say we initially had, what is the average kinetic energy? The total kinetic energy divided by say 10 particles. After, and here the average kinetic energy was sum of all kinetic energy divided by say 20 particles. 5 particles got transferred here. So the new equation is what? Average kinetic energy divided by 25, and here it is average kinetic energy, sum of kinetic energy divided by 5. Denominator बढ़ गया, so average kinetic energy will fall down ना, so इसका temperature गिर गया. Simple mathematics. Did you understand this mathematics or not? If some molecules are taken away from here to here, इसका average fall कर जाएगा. You all are 5 brothers. The average number of paneer you get is 6. If 3 more cousins come to your house, will you get 6 paneer? No. Same thing happening here. And यहाँ पे क्या हुआ? Since cousins went away, earlier we used to get 6 paneer, now we are getting 9 paneers. Yes or no? So here the temperature increases, here temperature reduces. That's why when you sweat, when we sweat, there is always, they say that you have the fear of catching cold. If you are playing anything, after you sweat, you are always supposed to put on a jacket, because sweating is one way in which evaporation will happen very quickly. Your sweat will dry out, right? And if the sweat dries out, you start feeling cold. And when you are cold, infections always happen at low temperature. Infection आना शुरू हो जाएगा. Then evaporation, people are using even earthen pot. Have you seen? तो earthen pot में छोटे छोटे होल कर देते हैं और उसके ऊपर क्या करेंगे? गीला सा कपड़ा लगा के रख देते हैं. So what is happening? Outside temperature is after some time is making that wet cloth get dried. So where is the wet cloth getting the heat from? From the water inside, and the wet cloth dries very quickly. So the water must get cooled very quickly. So evaporation will always bring cooling. जहाँ evaporation होगा, उसके आसपास cooling होएगा ही होएगा. Entire refrigerator works on the principle of cooling. The refrigerant is getting evaporated. We call it a evaporator, ना? Refrigerator के अंदर को evaporator बोलते हैं. So refrigerant is getting evaporated and it is drawing away all the heat. इसलिए आपका सामान ठंडा होना शुरू हो जाता है. That's it. Conditions, cooling by evaporation. So we are end of this unit. Now there are exam style questions. Please have a thorough read of this chapter. All you are going to expect is, we'll do some exam style questions in our next class, but all you're going to expect here is ATP based questions, logic based questions, graph based questions. Previous chapter we will get what type of questions? So from heat you will get one complete question which will be ATP based, logic based, graph based, Q equal to MCT based, application based, expansion in solids. और क्या है? यही तो पढ़ना है आपको. Right up? Next class we'll go for chemistry because we have done maths, so we have to wind up electrochemistry. ठीक है? Can I close now? Ashmita madam?
Yes, sir.
Bye bye then.